So before we started on this house, we did an initial test with the blower door, and we got a very, very, very high rating, which means that the house is very leaky. So we had 17,557 cubic feet per minute at 50 Pascal, which is equivalent of 20.9 ACH 50. And what that means is if a 20 mile per hour wind is blowing across this old house, then you're going to have almost 21 air exchanges per hour. That's how leaky it is. So we do want a tight house, and this was definitely not a tight house. And that's the equivalent of having a 12 square foot hole in the side of the house. We knew we could only improve from there. So what we did is added sheathing to the house. The original house did not have any sheathing. So we partnered with Huber Zip System and we added sheathing. Now, you typically don't test sheathing, however, we did, because we wanted to see what it would look like if we did not put any tape or any sealant. And it was still pretty leaky. It was an improvement over the original house, which didn't have any sheathing. It just had plaster and some drywall as part of the renovations. So we got it down to 13 ACH 50, which is about a 7.5 or 7.7 square foot hole, which is still smaller than the other one, which was 12 feet, but it's still pretty leaky. There were several different options for sealing the joints on the zip system, and we opted to go with all liquid flash, and Huber actually told us that this was the most liquid flash they've ever seen on a house. We just want to see how tight we can make a house with just using sheathing and liquid flash. Now we got it down to 0.3 ACH 50, which is less than a square foot. It's 0.1 square feet, a square foot hole in the side of the house. All right, let's talk about the effective leakage area. Now this is calculated by taking the total CFM, which is cubic feet per minute at 50 Pascal and divided by 10. So the original test that we had on the house was around 17,000 and change CFM. Divide this by 10, and we've got 1755 square inches. Now, if you want to convert this to feet, it's approximately 12 square feet. Now, this is a pretty large hole in the side of the house. So let's look at this house compared to the sheathing only, which is a little bit smaller in square footage, down to if we actually seal all the joints, how small of a hole you can get in the building envelope. Now, again, this is essential if you're going to build tight, ventilate right. First part of the equation is building tight. All right, so let's go ahead and measure these holes real quick and show the size of these. So we're going to start with the one that is 20.9 ACH 50. That's equivalent to 12.15 square feet. Next one is 13 ACH 50, and that's 7.71 square feet. And where we finally got, after we added all the liquid flash, we got down to 0.3 ACH 50, and that's the equivalent of having around a 19-20 inch hole in the house, square inch hole. So again, it's a lot smaller, and we're trying to keep it smaller than that. But this is the aggregate of all the different cracks and crevices inside the house. And you can see, this is essentially leaving a window or door open. That's how leaky your house is with the first two. So unless you're sealing the panels on the house and dealing with the air barrier on the outside of the house, you're gonna have a fairly leaky house. And even still, this was our first round. We didn't even go through and do any of the punch out yet with the vendor. So we probably got this down to like 0.1 because we took the spoke pencil around, found a few gaps. But again, this is significant, and the difference between this and this is literally this is just the sheathing that we installed inside on the house, and this right here is adding the liquid flash to all the seams as a sealant to keep the water and the air out. And you can see that greatly reduced the size of the hole. Now this video is part of a series on air sealing and insulating, so definitely check this out. Check out the house that we did this on, the experiment. This is not usually where you do a blower door test. We did the blower door test at this point to show the difference between mainly what a house was like with no sheathing, adding sheathing to it, and also adding the sealant to it to show that sealant on the sheathing makes a huge difference. Huber was our partner on this one. They wanted to do this experiment to show that their product, in fact, can exceed the energy code. Now this right here, the numbers that we got for this was at least 18 times better than the Georgia energy code and it was basically twice as good as we needed to meet the passive house standard, which is a pretty tight house. Thanks again for joining us on this journey as we continue to explore better building products and practices to help you have a more durable, healthy, safe, comfortable, and energy efficient home. For your convenience, we've uploaded other videos just like this. If you enjoyed this video, we appreciate it if you hit the like button and also hit subscribe and leave a comment below if you have any other questions about this topic.